6 to our science lesson. Today we're going to be reviewing forces. Now, I know we have done this before, but there's nothing harm in repeating it. You might catch a new idea you haven't noticed before, or learn a new thing. Okay, so I want you to focus on force diagrams in this lesson. Now, the most commonly used or the most common type of forces around us are pushes and pulls. Now, I want you to take a look at the picture below and see if you can define which one of them are pushes, which one of them are pulls. Now, in all of these images, there is something, some object moving. So that means a force has been exerted on one of these objects, so it makes it move. Okay? So let's imagine two guys falling from the sky. Um, there's a force pulling them to the ground. Now, can you name the force that's pulling them to the ground? Think about it for a minute. We're gonna see which one it is. It says on the slide, forces affect the movement or shape of an object. They can make an object start to move, stop moving, move faster, or move slower. They could also make an object change its shape or cause a moving object to change directions. Now imagine these two guys are hit by an airplane. An airplane is basically moving in a horizontal level, even though it's in the same height of these two guys. And the airplane is moving in a horizontal manner. These two guys are vertical. They're dropping. So if an airplane hits them, they basically are pushed in another direction. So that's what we mean when we say another force could actually make an object change direction. They will be pushed horizontally. Okay, so let's take a look at them. The force diagram for these two guys. Now, the first thing we know is that gravity is pulling them downwards. That's gravity is a pulling force exerted by the Earth. So the gravitational force from the Earth pulls in the direction towards the center of the Earth. Gravity is pulling the skydivers towards the ground. All right. Now, if imagine like at some point in their fall, they open their parachutes. Okay. So what happens? Air fills the parachute. They immediately have a force pushing them upwards, so it's working against the gravitational force. Okay, it says in this image you can see that a force is slowing the skydivers down. This force is pushing in the opposite direction to gravity, meaning gravity is downwards, this force is upwards. And basically the guys will keep on moving downwards. Now I want you to take a minute or pause the video, think about why if there is a force pushing them up, there's gravity pulling them down, but they're still falling down. They're falling slower to the ground, but they are still moving towards the Earth. Now the answer to the question is because gravity has a bigger force than the force pushing them up. So the gravity is pushing them down, it's the bigger force, so they're both moving in that direction. Okay, just like this. Now, when we say the air, there's a force pushing them up, we're talking about air resistance, because all the parachute is filled up with air, and the air particles try to push the surface of the parachute upwards. Okay, so on the slide it says air resistance is the name of the force that is pushing up against the parachute. Gravity is pulling the skydivers down, to the ground, and they are slowed down because the force or air resistance pushes against the inside of the parachute, and they descend more slowly. So gravity and air resistance in this example are opposing forces in this situation. So they're in the opposite direction. And be careful, this is how you draw it in an exam. You clearly draw the guys. You don't have to be very detailed, but you have to have some sort of a sketch for the object or the people that are, being affected by the force. And you need to have a straight arrow up for air resistance, a straight arrow down for gravity. And if they happen to have magnitudes, for example, if we set air resistance, for example, 50 newtons, and then gravity 100 newtons, what you do is that you subtract 50, which is the air resistance, 50 newtons from 100 newtons, which is the gravity, and the resulting, the result would be 50 newtons in the direction of the gravity, because you see the arrow of the gravity is bigger than the arrow for the air resistance. That means the gravity force is bigger one. That's how you draw a force diagram. You show a bigger arrow shows a bigger force, okay, and the object is moving, in the direction of the bigger force. Now take a look at this girl on a bicycle, okay? There's another force, we studied force, so you already know what this one is. It's basically if a girl is pushing herself, pushing and basically riding the bike, and she is pushing herself on the bike in the direction that she's going, which is like, to the right. But there is a force acting in the opposite direction, which is right here, this one. You see the arrow for the the direction for herself, pushing herself in that way is bigger than the direction of this force. That means the object or the bike and the girl are moving in that direction, and they're not moving in like a tilted line. They're moving in a straight line, so the force is supposed to be straight. Okay, so what do you think this one is? Obviously you should be able to know by now. Yep, it's friction. Friction is always opposite the direction of the movement. Saying this, if a man is walking next to the girl, he would have the same force diagram. Obviously, he would have less force exerted on him, because he's walking himself in that direction. This girl pushing a bike, both of them have different forces, but the idea is they're both moving to the right. Friction will always, if they're moving to the right, the object is moving to the right, friction is always moving opposite direction. It means friction will move to the left. Okay? On to another type of force. Imagine this guy is in a running stream, meaning the water is running. So he basically moves himself against the movement of the river. Okay, there's a force of the man pushing himself towards the right, and there is the water resistance that's in the opposite direction. Now the man is moving in the direction in which he pushes himself, so he's going this way, and also his force is pushing this way. But the water resistance is pushing in the opposite direction. But the water resistance, you see the arrow is smaller. The man pushing force arrow is bigger. So basically, this is the force that wins. So the guy moves, even though he will find difficulty in moving, but he will still move. Okay, so water resistance is another type. Like we have air resistance, we also have water resistance, which is also in the opposite direction of the moving object in the water. Okay, so imagine a ship basically floating in the water. There is an equal there are two forces actually acting on that boat or the ship. They're basically in the same magnitude, meaning they are equal to the same, newtons, so the arrows are the same size. Okay, so the boat or the ship really floats in the middle, doesn't really sink, and it doesn't really, go up more than that. At that point, on the surface of the water, the buoyancy force and the gravity force are equal. So that's how the ship stays right there. Now, buoyancy is another type of force. If this ship is not moving, the water particles, they are lifting the boat up. That lift is called buoyancy. However, if the boat is basically moving in a direction, the water particles will have, we know, water. It will have a force called water resistance on the object, opposite to where it goes. So, if this ship is going that way, the water resistant so the ship is going that way, and the water resistant particles, forces, the water resistance would be this way, so in the opposite direction. But right here, for gravity, we have buoyancy. Now, I want you to notice how it's a straight line, and it's straight, vertical, and it's downwards when we write gravity. Okay, and if this one was 500 newtons, the gravity was 500 newtons, the buoyancy is 500 newtons. So when you subtract them, it's 500 minus 500, which is equal to 0, which is 0 force. So all the forces acting on this non-moving or stopped ship are all 0. They're all balanced. This is an example of a balanced force. Okay, that doesn't mean when you say there's a balance of forces, it doesn't mean the forces doesn't, the forces don't exist. They do, but they cancel each other out, such as this one. Yeah. So on the slide, it says in this example, the boat doesn't really sink because there's a buoyancy force, upthrust. It's also called upthrust, created by the volume of the water. So the basically particles under the ship we're talking about. It's the balance of the gravity and the buoyancy that keeps the boat floating.